everyone, on behalf of State Council of Science and Technology and Environment, I would like to welcome you all to this online coaching class, especially to the class 10 student. Alright, so today I am going to teach you all about a very important concept which is taken from chemistry section of mathematics textbook for class 10, that is the acids, bases and salt. So let us get started with the class. Alright, today we are going to learn about acids, bases and salts. Right? We'll learn about acids, bases and salts. So before starting, right, I just want you all to be clear in here that acids, bases and salt are not limited just only in the chemistry lab or in the chemistry textbook. Alright, they are also present even in our everyday lives. So for now, right now I have with me here lemon, tomato, bitter gourd, bar soap, salt, sugar and a solution. Alright, first I want you all to list down which of these belong to the category of an acid, basis or salt. Alright, here I have lemon. Lemon we all know is a citrus fruit and this lemon contains a citric acid. So lemon belong to the category of an acid. Alright, even tomato also. Tomato also contain an acid which is called as oxalic acid. Tomato also belong to the category of an acid. So both of these, when we taste them, they have sour taste. So that sour taste is actually due to the presence of acids in them. Alright, the next I have bitter gourd. Bitter gourd is a vegetable and when we taste bitter gourd, we get the bitter taste. That bitter taste is due to the presence of bases in them. Alright, and next we have bar soap. This is the bar soap and this bar soap contains bases and the name of the compound is sodium hydroxide. So bar soap and this bitter gourd, they belong to the category of bases. Alright, next I have salt with me. This is the salt that we used to have every day and the name of the salt is sodium chloride. So this actually belongs to the category of salt. When we taste this salt, it has salty taste. There are many compounds which has salt. For example, chalk. Chalk also contains salt in it and the name of the salt is calcium carbonate. Next, let us see sugar. Alright, when we see sugar, what do you think? It belongs to which category? To the acid, basis or salt? So you need to know here is that sugar belongs to none of these. Alright, sugar is neutral. It does not contain any acid, it does not contain any bases, nor salt. Alright, so now I believe you have understand how to identify acids, bases and salt based on the taste. Alright, we know that those food materials which has sour taste are due to the presence of an acid. Food materials which has bitter taste are due to the presence of bases, and those which have salty taste are due to the presence of salt. But you know, we can't just go around and taste each and every item in order to identify acids, bases and salt. That is not possible for us because some of those items are dangerous and they are very poisonous to us. So we cannot rely only on the taste itself. Alright, so in that case, we will use indicators. What are these indicators? Indicators are the compounds that indicate or tell us whether the solution is acidic or basic. Alright, when this indicator comes in contact with an acid and with a base, it will either change its color or its smell. We have different types of an indicator. Some of them are turmeric, phenolphthalein, methyl orange and the litmus solution. Alright, so in this case, we will concentrate on the litmus. Alright, what is a litmus? A litmus is a dye. Alright, litmus is a dye. We have here litmus. This litmus is a dye. Alright, or colored substances. This litmus is extracted from a plant called lichen. So this litmus is a type of an indicator which changes its color whenever it comes in contact with an acid or with a base. Alright, so generally we have litmus will be available in two colors, one with red and the other one with blue. Litmus can be present in the form of a solution or in the form of a paper. Right now I have with me in the form of a paper. This is a litmus red paper, and this is another one, a litmus blue paper. So whenever this litmus paper comes in contact with an acid and with a base, it will change its color. So you need to understand here is this: whenever a blue litmus paper, right, comes in contact with an acid, it will change its color from blue to red. So for you to understand that, let me do this small experiment. Let me take one of the solution from here and let us see whether the color will change or not when we'll put this litmus blue paper inside this solution. Let me dip this one here. So here we can see that this blue litmus paper, it turns into red. So it means this given solution here is an acid solution. Alright, and the next point that you need to know is that what happened to the litmus red paper. Whenever you put in contact the red litmus paper, alright, with a base, it will change its color from red to blue. So to understand that, let me dip this red litmus paper in this another solution. So let's see whether the color changes or not. So when I dip this in here, so here we can see clearly that red litmus paper turns blue. Right? So you might be thinking, what happened if we put a blue litmus paper inside the base? Because a base turned red into blue. What happened if you put a blue inside the base? Will it change its color or does not change? So let us see. Let me put again the blue litmus paper inside the base. Alright, this is the base solution. So here we can see that this blue litmus paper does not change its color when we put inside the base. It will change its color only when we put it inside the acid. Alright, so the next, what about the red litmus paper? If you put inside the acid, will it change its color or does not change? So here, this is an acid solution. If I put it here, we can see that the color does not change. It remains red. Alright, so here you need to understand the general understanding that all the litmus blue paper or blue solution, when it comes in contact with an acid, it will turn red. You can try even with lemon. You can put the blue litmus paper in the lemon juice. You will clearly see that its color will turn red. Alright? And the next point is that the blue litmus paper, whenever it comes, the next point is that the red litmus paper, whenever it comes in contact with an acid, it will change its color into blue. Right? So here we see litmus when it comes in blue litmus when it comes in contact with an acid. Blue litmus turns red when it comes in contact with an acid. Alright? And then next, same thing, blue litmus remains blue when it comes in contact with a base. Alright, next what about the red litmus? Red litmus turns blue when it comes in contact with a base. Right? And next, red litmus remain red when it comes in contact with an acid. Alright, so I believe you don't get confused this. Alright, in order to understand this, you can use this small concept, that is, alright, BRB. That is, base turns red into blue. Alright, base turns red into blue. Base will change red color into blue. So you will understand, if base turns red into blue, then acid will turn blue into red. Alright? So another important point you need to understand here, what happened if you dip this litmus in a salt solution? What happened to its color? So you need to know here is that whenever you dip this litmus, alright, any other indicators also in the salt solution, their color remains the same. Alright, it does not bring any changes in their color. Alright, so now having understood how to identify acids and bases, alright, either by tasting or by using indicators, let us now try to understand very clearly what is an acid. Alright. What is an acid? Right? Before starting, very important point you need to know here is that all acids contain hydrogen in common. Alright? Hydrogen must be present in every acid. We cannot have any acid without hydrogen. Alright, so what are the compounds that are an acid? So they are hydrochloric acid, that is the HCl, then sulfuric acid, H2SO4, nitric acid, HNO3, and then acetic acid, CH3COOH, oxalic acid, COOH2, and some more. Alright, so these are few of the acids, and you can clearly see that all these acids here, they contain hydrogen. Alright, then now, the next point you need to understand is that acid will show its acidic behavior in the presence of water solution. Alright, it will show its acidic behavior in the presence of water. Of course, hydrogen also must be present in the acid, alright, but water also has to be present. Okay, so here let us take this equation. For example, HCl, alright, here in AQ. When we say AQ, it means aqueous in the presence of water. So this HCl, this is hydrochloric acid, it will breaks into H plus ion and chlorine and ion. Alright, Cl minus. So from this one, it will breaks into H plus and Cl minus. This is the ionic equation. Alright, so this H plus ion here is very important. because it will show the acidic nature of the solution, right? And the very important point you need to understand is that H plus ion cannot exist alone, right? In reality, it will come in contact with water molecule in order to form hydronium ion, right? So next we'll have that H plus actually will react with water molecule. So this will get to H3O plus hydronium ion. This is the hydronium ion. This is in reality. Not only H plus alone will present, alright. So it will actually combine with water molecule to get hydronium ion. So in reality, the actual equation will be HCl plus H2O will get, see in here, you need to understand is that H plus will come in combined with water to get hydronium. So it means this water will get in contact with H plus. So we'll get H3O plus and then we'll have Cl minus. So you observe this one very properly. It is this equation only. The only thing is this H plus will combine with water, will get hydronium ion. So this is the actual equation of an acid. From here you can define what is an acid. An acid is a compound, right, which on dissolving with water gives hydronium ion. This is the hydronium ion. So you can form another equation with even with sulfuric acid, even with nitric acid, or even with acetic acid. You can try that at home, right? Then the next point that we need to understand here is what is a base, right? What is a base? Alright. You might be thinking, what kind of a compound actually represents base? Alright. Very important point you need to remember here is that all metal hydroxides and metal oxides are bases. Alright. Metal hydroxides and metal oxides are bases. So what are those? They are like sodium hydroxide NaOH, potassium hydroxide KOH, magnesium hydroxide MgOH2. You can have some more. These are the metal hydroxide. Another one, metal oxide like lead oxide PbO, zinc oxide, copper oxide, and some more. Right. So these kind of a compound which contain the hydroxide and the oxide, they are the bases. Right. So here, what is a base or define bases? We have many definitions. One of it is that bases are the compound which on reacting with an acid, they will give salt and water. Alright, bases are compound, bases are the compound Base are the compound, alright, which on reacting with an acid, alright, will give salt and water. Alright, this is the definition of a base. Now, listen here. These compounds here are the base, and some of these compounds can either dissolve in water or does not dissolve in water. Alright, so those compound, or those bases which dissolve in water, they are called as alkali. Alright, those bases which are soluble in water, they are called as alkalis. But those bases which are not soluble in water, they are not called as alkalis. Okay, so if somebody asks you define alkalis, alkalis are the bases which are soluble in water. water. So some of the alkalis are sodium hydroxide, potassium hydroxide, even magnesium hydroxide also, but it is partially soluble in water. Alright, alkali we have a base which is soluble in water, So some of the example: sodium hydroxide, potassium hydroxide. Right? So now I believe you have understood very clearly how to define acid and bases. So we will stop it till here for today, and in the next class we will try to list down the chemical properties of acids and bases. Until that time, thank you.